On December 27, 2024, a telescope in Chile detected an object that would become the highest-rated asteroid threat in modern history. Scientists calculated that while the probability of it colliding with Earth in 2032 was small but measurable, 2024 YR4 dominated headlines for weeks. Then, in an extraordinary display of planetary defense capabilities, this threat was systematically eliminated. Earth is safe. But the story doesn't end there. When the probability of impact with Earth dropped to zero, a different scenario emerged. The same asteroid that once threatened our planet now has a 4.3% chance of hitting the Moon on December 22. It's not dangerous, but it is scientifically extraordinary. It will be the most energetic lunar impact ever observed in human history, visible from Earth and capable of producing data that could reshape our understanding of impact physics. Let's now explore how we got here, what makes this unique, and what scientists have planned. Asteroid 2024 YR4 was discovered at the Asteroid Terrestrial Impact Last Alert System facility in Rio Hurtado, Chile, 2 days after reaching its closest point to Earth. The asteroid was coming from the direction of the Sun and was hidden in bright light that ground-based telescopes struggle to detect objects in. This blind spot was the reason it went unnoticed until it passed by. When it was discovered, automatic collision tracking systems immediately flagged it. Initial orbit calculations based on limited observations showed a low probability of collision with Earth exactly 8 years later, on December 23, 2032. What happened next was unprecedented. Within a few weeks, as more observatories tracked the asteroid and determined its orbit, the calculated collision probability did not decrease as expected. By late January 2025, the probability had risen to 3.1%, and 2024 YR4 reached a Torino scale rating of 3, which measures the risk of an asteroid collision. No asteroid in the modern era had ever received such a high Torino score. The last to come close was Apophis, which reached 4 points on the Torino scale in 2004, but was later ruled out. The International Asteroid Warning Network issued its first-ever potential impact alert. Planetary defense protocols developed over decades but never fully tested in a real scenario were activated. Major observatories worldwide prioritized tracking the asteroid. The Near-Earth Object Research Center at NASA's Jet Propulsion Laboratory coordinated the tracking efforts. The European Space Agency's risk assessment systems went into high alert. For the first time, the global planetary defense community faced a real near-Earth object requiring coordinated international intervention rather than a drill or simulation. The asteroid itself posed challenges. Estimated to be between 50 and 70 meters in diameter, equivalent to a 15-story building, the asteroid fell into the city killer category. If it struck land, it could cause damage in an area extending up to 50 kilometers from the point of impact. Major cities in South America, Africa, and Asia were within the potential impact zones calculated from early orbital data. If it had struck the ocean, models indicated a low probability of the energy release generating a significant tsunami, but if an airburst had occurred over a populated area, windows could have been shattered and structures damaged across a wide area. What made examining 2024 YR4 particularly difficult was its timing. Discovered as it was moving away from Earth, the asteroid rapidly dimmed as it continued its orbit around the Sun. Even large instruments like the 10-meter Keck telescope and the Very Large Telescope struggled to maintain observations. By mid-March 2025, the asteroid's apparent brightness had faded to magnitude 26, which is 63 million times fainter than objects visible to the naked eye. It was slipping beyond the reach of Earth's most powerful observatories. That's when the James Webb Space Telescope stepped in. Between March and May 2025, Webb's infrared instruments made important observations before 2024 YR4 disappeared completely. These observations served many purposes. Webb's near-infrared camera provided precise position measurements that improved the asteroid's orbit by approximately 20%. The telescope also measured the asteroid's thermal properties, confirming it was an S-type asteroid composed primarily of silicate rock and nickel iron, similar to targets of past sample return missions. Webb data showed that the asteroid was not a loose pile of rubble, but a coherent rocky body. This meant that the asteroid was not a structure made up of loosely bound pieces, but had structural integrity. By late February 2025, the accumulated data was definitive. Earth was no longer in the asteroid's potential collision corridor. The probability of a collision with Earth dropped from 3.1% to 1.5%, then to 0.3%, and finally to effectively zero. The threat was over. The planetary defense systems had worked exactly as designed: early detection, coordinated tracking, precise orbital calculations, and definitive elimination of the danger. However, as Earth exited the uncertainty zone, the Moon entered it. The final observations from Webb and ground-based telescopes in May and June 2025 showed that the probability of 2024 YR4 colliding with the Moon, The probability of the asteroid completely missing is still 95.7%, but the remaining probability is significant enough to warrant scientific preparation. If the collision occurs, it will strike the near side of the Moon, the side always visible from Earth, on December 22 at Trothau, approximately 1519 UTC. The estimated impact energy is equivalent to approximately 6.5 to 7.8 megatons of TNT, about 500 times more powerful than the Hiroshima atomic bomb and about half the energy of the 1908 Tunguska event. The Tunguska event flattened an area of 2,000 square kilometers of Siberian forest. Since the Moon has no atmosphere to disperse the energy, all the force will be transferred directly to the surface. Models predict that a crater approximately 1 kilometer wide will form. This crater is comparable to the meteor crater in Arizona, but it will have formed in seconds, not over thousands of years of erosion. For scientists, this represents an extraordinary opportunity. All large craters on the Moon formed billions of years ago, long before humanity existed. Modern impact physics relies on simulations, crater analysis, and observations of rare small impacts. A 60-meter asteroid striking the Moon at its encounter velocity would be the most energetic impact event ever recorded with modern instruments. Astronomers predict a brief optical flash visible from Earth due to the rock's instant vaporization, followed by a long-lasting infrared glow as the molten material cools. The impact will occur during the Moon's waning gibbous phase, approximately 70% illuminated, making it large and bright in Earth's sky. The best viewing location will be the Pacific Hemisphere. Observatories in Hawaii, including Keck, Subaru, and Gemini North, will have the best view. These facilities recently proved their ability to document rare celestial events by capturing striking images of the interstellar comet 3I Atlas. The west coast of North America will be able to see the collision around dawn, close to the Moon's setting. South America, Europe, and Asia will face more challenging conditions due to the Moon being low in the sky or daylight. Beyond the flash, seismic instruments on the Moon can detect vibrations spreading across the entire lunar surface. In the past, even small impacts have produced measurable signals in lunar seismometer networks. An event of this magnitude will likely generate global lunar tremors and provide unprecedented data about the Moon's internal structure. The impact will also eject material. Models show that tens of millions of kilograms of lunar debris will be ejected from the crater, with some fragments reaching or exceeding lunar escape velocity. This ejected material will spread into Earth-Moon space, creating temporary hazards for satellites in high Earth orbit and around the Moon. If NASA's planned Gateway station becomes operational by 2032, it will need monitoring data to assess debris risks. The same applies to commercial lunar missions or infrastructure established by that time. A small portion of the launched material could be gravitationally bound to Earth, creating a brief meteor shower as fragments burn up in our atmosphere, a visible reminder of the collision weeks or months later. The asteroid is currently too distant to observe. It will not be visible again until it approaches the inner solar system in 2028. This encounter will provide a new observation opportunity. Additional tracking data collected in 2028 will either reduce the probability of a lunar impact to zero or confirm that this possibility is real as December 2032 approaches. Either outcome will advance science. If the impact is confirmed not to occur, current tracking and prediction capabilities will be validated. If the possibility persists, years of preparation for coordinated global observation campaigns can be undertaken. What truly makes 2024 YR4 significant is not the low probability of a lunar impact, but what this entire event reveals about planetary defense preparedness. For the first time, the international community faced a potential collision scenario requiring real coordination, not simulation. Detection systems worked, tracking networks responded, orbit calculations systematically improved, public communications managed the uncertainty without causing panic, and ultimately, the threat was definitively eliminated. One researcher described 2024 YR4 as a perfect fit for planetary defense efforts. It has everything needed to grab our attention. That attention resulted in the most comprehensive real-world collision warning system test ever conducted. Future research, including ESA's planned Eniomir Space Telescope, specifically designed to monitor the Sun's blind spot, will reduce the likelihood of missing such objects. Improved infrared space-based detection will identify threats earlier, allowing more time for intervention. The countdown to December 2022 has begun.